Hello, because the previous course was getting too long, I decided to break this course apart so it will be easier for you to search for topics that you are interested in. Anyway, we will continue by looking at how to calculate the total capacitance when capacitors are placed in parallel or series. Let's start with capacitors connected in parallel. Much like resistors, multiple capacitors can be combined in series or parallel to create a combined equivalent capacitance. Capacitors, however, add together in a way that's completely the opposite of resistors. As you can see here, we have three capacitors placed in parallel, and if you were to measure the total capacitance from this point to this point, you will measure capacitance which is the sum of all the capacitances. So when capacitors are placed in parallel with one another, the total capacitance is simply the sum of all capacitances. And this is analogous to the way resistors add when they are placed in series. So for example, if you have three capacitors of values 0.1, 0.2 and 0.3 microfarads in parallel, the total capacitance would be how much? Yeah, it's written here, 0.6 microfarads. Also, what you have to know is that by connecting several capacitors in parallel, the resulting circuit is able to store more energy, since the equivalent capacitance is the sum of individual capacitance of all capacitors involved. But remember that voltage applied to parallel connection is the minimum voltage rating of one of the capacitors. So for instance, if 200 volt capacitor is connected to, let's say, 100 volt capacitor, the entire voltage rating is 100 volt and not 200 volt. Also, we will see in the future, and you will see in circuits, that many times few capacitors are placed in parallel, but not to increase the total capacitance. So not because of that. When we will study about filters, you will see that each capacitor, depending on its type and size in terms of capacitance, it can filter out undesired signals of different frequencies. So let's say one capacitor will filter out low frequency signals that are below 1 kHz, and the other capacitor will filter out high frequency signals that are beyond 20 kHz. But more on this later. Now, much like resistors are a pain to add in parallel, capacitors get funky when placed in series. The total capacitance of n capacitors in series is the inverse of the sum of all inverse capacitances. If you only have two capacitors in series, you can use the product over sum method to calculate the total capacitance. Taking the equation even further, if you have two equal valued capacitors in series, the total capacitance will be half of their value. Alright, as an example, if we have three capacitors of values 100 microfarads, 220 microfarads and 470 microfarads, the total capacitance will be 59.98 microfarads. And I will let you to do the math and see if this is correct or not. If you have any questions though related to this topic or something else, don't hesitate to leave a comment below. So thanks for watching and see you next course.